Hi guys, welcome to Graphs 3 or Graph Theory 3, the third session in learning about graphs. In the last class, we have seen how to shift a graph up or down, left or right. Today, we're going to stretch ourselves, rather, we're going to stretch the graphs. So we're going to look at a topic or a small manipulation which will help us stretch up, elongation, or stretch horizontally a graph, or contract horizontally or contract vertically. Okay, so today we are going to look at the topic called scaling of graphs. How do you make a graph larger, that is vertically larger, horizontally larger, or horizontally compressed or vertically compressed? That's what we're going to look at. Well, that's me. Quickly moving on. Right, so we look at the simplest of changes. Now this time, in the last class, we have seen that there is no shape change. It is only shifting. But now, because of the contractions or the elongation, stretching, we will see a change in shape. So the manipulations in today's video definitely change the shape of the graph. So let's look at two types of manipulations that we have. They are called elongation and contraction along the vertical axis or the horizontal axis. So we will see, when does a graph contract horizontally or vertically? When does a graph elongate or stretch vertically or horizontally? That's what we're going to learn today. Right, so vertical shape changes. When does a graph shape change vertically? So when you have an f of x, if the graph of f of x is known, and you're multiplying your f of x with a, when you're multiplying f of x with a number called a, then there will be a vertical change shape, not horizontal. It's going to be vertical change. Now, what does it mean? Let's take a look at it with an example. You have sin x. There's your graph. You know what is the graph of sin x. Now I want to find out the graph of 2 times of sin x, which means I'm multiplying your f of x. This is your f of x. I'm multiplying and writing it as 2 times f of x. So this is what I want to find. Now this basically tells you, and if you look at the graph, you will observe that the green part is the graph. You can see that this point has been stretched up. It is not moved. Please keep in mind, it has not moved. It has been stretched up because the points over here and here are the same. They are not changing. Okay, this point, so think of it as they are clamped. The roots are clamped, but the graph has been stretched up. You have just pulled it up, stretched it up, not pulled, sorry, stretched it up. Similarly, this point has been stretched down. So any point on the positive side will be stretching to go up. Any point on the negative side will be stretched to go down. So the output, or basically the takeaway from our graph analysis here is that when you have an f of x and you want to find out a times of f of x, then this basically will be a vertical elongation. Keep in mind, a is greater than 1. A is greater than 1. Okay, so it will be a vertical elongation. Horizontally, it will remain the same. So you can see the roots of sin x are not changing. They are the same. Okay, so it is not going wide. It is the same. It's just that it is becoming taller. Taller means not just upwards, both positive and negative side taller. Let's look at the next. What happens? When does it contract then? Vertical contraction. Now, if you have your sin x, but this time I'm using my a, which is less than 1. Basically, I'm taking a fraction. Fraction means you can see the graph which is in blue color. You can see that the graph, both graphs of half sin x and sin x, the roots are still the same. The same roots are there, which means horizontally nothing is changing. But you can notice that my sin x is being compressed vertically. So as if somebody is compressing it like this. And you can see it is happening both sides. Okay, it is happening both sides. Now you might ask, how do I know how much is it getting compressed? How do I know how much is it getting compressed? Basically, this a itself will tell you. Half basically means every point should be made half. That's the meaning. Previously, 2 times means every point should be doubled. So when every point is doubled, 0 will remain 0. In fact, when 0 remains 0 and every point is doubled, that is why we had vertical stretching. So you can see that in the vertical stretching, we had 0 remaining as 0, but every point is getting doubled. So you can see this point, which is 1, is now doubling to give you 2. This point, which is -1, is now doubling to give you -2. So it is doubling. Similarly, if you look at half, everything is becoming half. So A tells you, the value of A tells you whether you are doubling it or reducing it, and if you're reducing it, by how much are you reducing? Okay, that's very simple and straight away for you to understand. The next we look at is, when does a graph, so this is horizontal, vertical contraction, we have seen this. The next is horizontal shape changes. So till now we have seen vertical shape changes. Now we will look at horizontal shape changes. So what is the meaning of a horizontal shape change? When you have f of x and you want to modify it into f of a plus x, this is when there will be horizontal contraction or elongation. Okay, there will be horizontal contraction or elongation. Let's take an example. So let us say I have taken a cubic equation. This is my f of x. It's a cubic equation, right? Now, few things to keep in mind. This point here is 1, 2, and 3. So the roots are -3 and -2. And you have one more root here, +1, +1. Okay, so this is the graph. Now I want to find the graph of f of 2x. What happens when I want to find f of 2x? When 2 is inside your function, then you can notice that my graph, so this is the original graph. Now this is getting compressed. It is getting compressed horizontally. It is getting compressed horizontally, and you can see that the root, which is -3, is now becoming this -1.5, because this is 0 and this is 1. This is -2. So in between them is -1.5. So this becomes your -1. And the positive root that you had here, positive root was 1. It is now becoming half. This is half, 1/2. So why is it becoming half? Because of this 2. So when 2 is inside, everything is becoming half. So when you want to find f of ax, where a is more than 1, then the entire graph will start getting compressed horizontally, such that every point becomes 1/a times of itself. Every point becomes 1/a times of itself. So you can see -3 became -3/2, which is -1.5. Right? This 1/2 came because of this a, which is the 2 over here. Similarly, the root -2 became your -1, and the root +1 became your half. So everything became half of it. Half means compressing. The one thing you need to notice is vertically the answer did not change. So you can look at it. This was just below your 1, just below 1. And here, this is your 1. And you can notice that both graphs, the y part will not change. It will still be the same, just below 1. Right? This is also just below 1. So as I said, vertical change will not happen. Vertically, the points that were there will stay the same. But horizontally, they will compress or expand. That is what happens when you're looking at f of ax. So by now you'll already guess what happens if it is f of x/2. As you can all understand, I mean, you can guess by now. So we will just take an example to look at it. If you want to look at the same graph, but now I want to take half of it, x/2. x/2 means, you can notice that this is the green graph, which is a modified. So everything will become double. So the original root was -2 or -3. Now the root becomes -6. Original root was -2. Now the root becomes -4. Original root was +1. Now the root becomes +2. However, vertical still says the same. Vertical point still says the same. It doesn't change. So when you have f of a or x/a, then you are basically elongating or pulling the graph horizontally. Okay, so remember, when you are dividing the x, then you are pulling the graph. When you are multiplying x, then you are compressing the graph. when you're multiplying x with the a which is greater than 1, you are compressing the graph. Right, guys, so with that, we will end our session here. In the next session, we're going to take a couple of more interesting topics, which is about reflection of a graph and symmetricity of a graph. See you in the next session. Thank you.